I just want to do an aside here about equality. We did a very simple thing. We just compared two strings, and of course this is what you would expect to be able to compare two strings, but a lot of the time in Java you're sort of expected to implement equals yourself if you wanted to define equality for something, and you would and if you didn't implement equals you would get reference equality, which would just fall back on sort of looking at the identity of essentially the pointers to sort of compare that this is the same pointer. Now in Clojure, all the Clojure data structures are, they implement a very good version of equals, which allows you to not care about this at all. You can do, you can pretty much just assume that equality is, it's basically called structural equality, which means that if something looks the same, if it has the same stuff in it, it's equals, right? But you can also do like, you put a string in here, and I put a string in here that's, oh, this will be a bit confusing maybe. Just let's do that again. So str is a function that concatenates strings. So if I do hell and o and concatenate that, I'll just show you in the REPL, hell and o turns into the string hello. But here I'm comparing a string literal to something that would create a new string and put it on the stack and stuff like that. And if I evaluate that, if I evaluate that, it still compares to true because it's comparing the actual stuff inside, right? And this works recursively. You can dig down and have a very complex thing. You can have two different sets that have been created in different fashions, but if they contain the same stuff, regardless of the actual layout, it will equate to the same. And there's an inverse operation for comparing if something is not the same, and it's a bit cute because it's called not equals like that. But yeah, equality is sort of, you get that for free, and you also get hash code for free. And the nice thing is that it's actually sort of caching the results of this a little bit. Once you evaluate hash code for something, it has sort of memoized and cached that result, so it won't have to do the whole figuring out if something has the same hash code. So equality is actually kind of quick to do. It sounds like it would be expensive to evaluate, but it is actually very quick.
So does not equals also take any number of arguments?
Yes.
And what is the result of that? That none of them are equal, or that there's at least one that is not equal to the rest?
Oh, you really stumped me now. I need to go to look at it. Okay, so it evaluates as not and then equals all the stuff. Okay. So it's just sort of, yeah. You use this you can inside IntelliJ you can just command click on something to get to the definition of it, and you can sort of read the source code and look it up if you need to. Right, so that's that bit. Now, let's see. Yeah, so that's equality, and you can, of course, you can do equality with very complex stuff, because this is used under the covers as well. There's a function called contains, which will check if something is a member of a set or map, and if I have a set of A, B, and C here, oh, actually, let's do like strings A. I don't know, something like that. You can ask if this thing contains the string hello, and you can use the, you can of course construct that, and this will also work. I mean, it's because equality is used by everything, and yeah, I guess you would sort of expect that to work, but I just want to sort of demo that you could have a fairly complex thing that you look up in a nested data structure, and it would still work. Now let's look at branching. Now branching in a lot of programming languages, there's like if, then, else, if, then, else, if, else sort of thing. Clojure is very sort of minimalist in what it in the fundamental bits, and then there's additional stuff built on top of those fundamental bits. But if in Clojure is like the lowest possible implementation of if. So it basically takes a test, and it takes an argument to return if the test is true, and an argument to return if the test is false. So if essentially acts like this guy in C. If you do like A is equals test yes, no. So that's what if is in Clojure. If test, oh wow, yes or no. So we could replace this if equals hello that yes nah oh so you have this very small thing where it's like the ternary operator with the additional thing that you can remove the else case, and if you remove the else case, it will evaluate to nil. Oh, that's not really. I guess not. I guess. So there you go. And using this, if you wanted something more complex, you would have to sort of either nest them like this. But that kind of gets messy after a little bit. So there's actually a construct called cond, which does what you would expect the if then else thing to do. Oh yeah, there we go. So you do like cond, and then you do like something like that. Yes. Oh. Yes, again, I guess. So you would keep doing this. You would like, it will sort of go from the top to bottom, and it would evaluate each thing. And the first thing that returned true, it will stop on that, and that will be the value of the cond expression. And so if you wanted to like have a fallback that is always true, you could put like true at the bottom, and then it was like default, I guess. You just put like what you wanted to be the result of that expression at the bottom. So you can do something complicated like that. And of course these nests, so if you wanted to put an additional cond here, you can do that, and you can create like a real branch monster. But the interesting thing about both if and cond, and basically everything in Clojure, is that it always returns a value. You don't really do if something print. Well, you do that, but if you do print will return nil, and nil will be the result of the if expression. So you can always think of if as the ternary expression, like the ternary operator. That's how it works, right? It always returns something. Yes, question?
Since it's expressions, is both cases always evaluated?
No. The thing about if is that it's like one of the built-in operators, and what it needs to be built in because it will only evaluate the case that matches. But it's also the only thing that's actually built like that in the entire language. And everything using that single construct, you can implement stuff like or, because you would then that or can turn into a nested if statement that just sort of propagates down, right? It's just cond is also can also be implemented in terms of if. And we're kind of moving a little bit to the future. I didn't really intend to talk a little bit very much about this, but the thing that enables this is that you have a macro system. You can define macros that return code, and when you evaluate that macro, it will sort of output code in place of itself. And I'm not going to look at cond because that's fairly complicated, but we can look at or probably. So or looks like this, and it's like or false, true, right? So it will sort of like evaluate one of these, and you can do like, oh, sorry. We need to put some. So or looks like that, or false, true, true. These would be expressions instead of just Boolean literals. But we can look at the macro definition for or, and you can see this bit here. There's a bit of noise here, so don't look too hard at it, but essentially it does let makes up an imaginary name for a local variable and puts the expression that you supplied as the first argument there, sort of injects that code in place of the let, in place of the x here. And then it does the if thing. It evaluates if this was truthy, like it's non-nil, it's not false, it will return that bit. And if it's not, it will keep going. It would sort of put the next bit in, which it's just be the next token. So you can see that OR is implemented in terms of if, and it would sort of just, the let bit here is just to avoid having, because it's a macro, it would sort of inject the same thing over and over. So if it would be a single if without a let, it would sort of evaluate the first part twice, right? So you don't want that. So it binds it to let. Yes, question?
About the quality, what about the quality between types, like strings and integers, and like 1 and 1?
Yeah, it's not gonna do like type punning. So the string that contains a 1 is not 1. It's not the number 1. Hello. No, sorry. There we go. So it doesn't do any automatic thing like that ever. Well, it kind of does in collections. Like if you're doing equality between sequences, like if you have two ordered collections, one is a list and one is a vector, it will consider them equivalent if the elements are the same elements in those two. It doesn't care about the container, it cares about the sequence. But and I think you can also do, like, if you have a sorted map and you compare that to an actual map and they have the same contents, I think they will be considered equal as well. But it doesn't do anything like numbers are not strings. It's not like JavaScript where they are equivalent in runtime. All right, so that was a bit of an aside about if and branching and stuff. Now, one annoying thing with if is that as it is exactly the ternary operator, like the just gonna clean this up a little bit, because if is always equivalent to this bit that you might have seen from other languages. If you wanted to do something complex in one of the branches, it might be a bit annoying, because this evaluates the test and then it returns either yes or no. If you wanted it to do more stuff, you need to sort of wrap this somehow. And there's a construct from that called do, which lets you list one or more expressions, and then the last one is the result. But you can do like, I'll do some logging here. Log no. So as you can see here, if it's true, I just run this bit and return the yes string. If it's false, I log no and then return no, because that's the last bit there. And as you can see, it puts log no and no there. Just gonna raise this a little bit. So there.
What happens with a comma-separated list in C++ too?
Yes, I mean it's the same. It does kind of the same thing. Now this is a lot of times you might be wanting to do something for the side effects itself. You want to do like if do and then do something, right? But you don't want to do like if do. There's a shorthand. There's a macro for that as well. So if I wanted to have something that looks like this, if I just wanted to. I just wanted the side effect of doing a bunch of prints here. No. Oh, and I guess I will have to do it. So this one will print two things, but I needed to put them into a do block because there can only be one expression in there. This is so common that there's also a shorthand for that called when, which does the same thing. Like then I can do the test, and then I can do any of these without. I can just sort of exclude the do. It's implicit. There's an implicit do, so it becomes like that. So these two ones are equivalent. You can skip the do and do a when. And honestly, often when we're doing this in code, we're kind of using when everywhere there's no second. Like when there's no else branch, we use when just as a convention because we wanted to. It makes it clear that there's only one thing that can happen there. Yeah. Okay. Now we have also the and or stuff. So let's do another function just for fun. We're calling this acceptable number. Is it or not an acceptable number? Well, if it is, or if it's odd, I accept it. Or if it's and, even, and I only accept numbers that are less. Let's just. I'm just gonna type this out and then talk about it because I'm confusing myself now. Right, so this number is either acceptable or unacceptable. And here you can see I'm nesting an expression. So or will evaluate this bit. If that is true, it won't evaluate this bit. We already looked at the or macro, so you know that it cancels out. The and macro does the same thing, that it will evaluate that. If that is false, it won't even bother with this one. Now, this one is one of the more confusing ones because often when you're talking about what I learned in school when you're talking about the sort of the comparison operators, the little these ones, is that this was supposed to be like a crocodile that was always eating the biggest number. And when it's doing this prefix notation, you can't really tell which number it's eating. But what the shorthand to think about this is that if the numbers are expanding upwards, if they're larger in that direction, if they're growing in that direction, it will evaluate to true. So this can actually put like additional numbers here. So I can do like, let's put in here actually. So is 1 greater than 0? Yes, it is, because it's expanding, right? And I can keep on doing this. So I can put like, all these numbers are expanding. But if I put a 6 in here, it's no longer true because it's not expanding anymore. It's not growing with every number. So this is actually quite useful because you can do like very quickly find out if something is within a particular range. Oh, that's not actually in that range though, is it? Because it's, sorry. God damn it. That's in that range. Otherwise you would have to do like that if you wanted to include the endpoints of it. Okay, so we define this and you can see the or and the nested and expression, and you can type this out. Now, the syntax of any Lisp language is kind of hostile in that it can be quite hard to read if you're unaccustomed to it. This you kind of get a little bit better about reading it after a while, and also it really helps here that I have a mode here called rainbow parens, which sort of makes all the different parentheses in different colors depending on the scope, so you can see what they're actually sort of assigned to. But here I've also tried to sort of make it a bit more clear by using indentation to see what is grouped together. So you can see the and expression here sort of groups these bits together like that, and the or expression expands a bit larger than that. Yeah, so that's I think some fundamental stuff that we talked about. Are there any questions so far? Yeah.
The and expression there to check for nil and stuff like that?
It's not there to check for nil, but it can be used to check for nil.
Otherwise you can remove the and expression.
Yeah.
You just put less than 10.
If it's not odd, it has to be even. That's what you say.
That's true. So yeah, there's no point in that. I just sort of I guess I was drunk when I typed that out. So there we go. I guess. Oh, actually, it's not strict, or is it? I don't know. What about 0?
0 is even.
Sure is.
Yeah.
Mm.
Since it's not odd.
Yes.
It has to be even.
Wonder if that's yeah. So oh yeah yeah. I guess it's not even. I guess. So that's yeah. All right. Well. Yeah. Okay. I guess not a number is a number.
Definition and even numbers has.
Yeah.
You can divide them by 2.
Yeah. So maybe I need to revise my example there, but that's yeah. Sorry about that. I think if you want to take a short break, this is a good time to do it, and we can. But I guess this is taking a lot more time than I thought it was. I'm about like nowhere near about what the stuff that I wanted to talk about, but we could, I guess, split it up a little bit as well. I guess we have the room to 12.
Yeah, we have 20 more minutes. I guess it might be a bit wiser to use this 20 minutes for questions and discussions, and then continue next time.
Yeah,
but
it might
that's
be.
my opinion. I mean, like,
Yeah.
have more people in the room.
Yeah. I mean, so some of the other stuff that I intended to talk about, just to sort of give you an idea, I wanted to talk about the interop with Java a little bit, like how you call stuff for Java functions. Sorry, yes, a question?
Complex numbers, are they part of the language?
I don't think so. I mean, the language has support. Yeah, you have a numeric tower. I'm not sure about complex numbers, but it does like ratios. So if you do like how do we do it? 1/3. That's a number that is evaluated to a third, and it's an exact third. So if I wanted to multiply with that with something, I can do like. I'm not really sure. So I guess I could do it like that again, and it would probably be. Yeah, there we go.
How about odd and even and ratios? Do they add it to like 4/2 even?
4/2. So you mean like that?
Yeah.
Let's find out. God damn it.
Yeah.
Sure is. Right, so I wanted to talk a little bit more about the interop with Java is another thing I want to talk about. I wanted to talk about the different collection types in more detail about how to manipulate them and that sort of thing. And I also wanted to talk about working in a functional language, like how you would solve problems using a functional programming language. We haven't really touched on this yet, but it's one of the key things with Clojure is that you try to avoid mutating state as much as possible. You don't really have a variable that you can sort of assign to multiple times. Everything is a constant, pretty much. So how you would go about actually solving real life problems, and I wanted to also give an example about like how working in the REPL like this and working with actually building like a small game-like thing, how that would pan out. But yeah, we probably should do a little bit more questions. I don't have time to cover all of that in this session. It seems like it took a lot more time than I expected, but yes.
I can comment on that. There's, according to a quick search on Google, there's no complex numbers, so you have to implement them. And so you can define your own types.
You can still break the separate number with a third, for example. You have to have the even if you remove, otherwise a third would be an acceptable number, even though it's not even, because it's less than 10.
But that's, I mean, the point of the I don't want to have it because it's less than 10. It's only an acceptable number if
but it's not equal. Yeah, your question was is it equivalent removing the even part?
But I think, but wouldn't
No, you can give. You're saying you can give it something that's not a whole number.
Yeah, exactly.
but then I mean this is in terms of not if. I don't think this is a very good use of our time to talk about this particular detail, but I would assume that I can remove it because it's actually defined as not even, and so it, yeah. All right. Yeah, sorry I didn't get into more detail about the fun stuff because this was really fundamentals, but I guess we'll have to take it a little bit at a time. And you know, I hope you found this little introduction a little bit interesting, and if you're wanting to show up for the next one, I guess we'll book a future date in that case. Any further questions? All right.
Maybe, I don't know if it's too much time consuming to because some Lisp-like languages are tail recursive, and I think Clojure is not, right?
No, Clojure does not have. So what we're talking about there is like a lot of the time in Lisp languages, people tend to want to solve problems using recursion. And if you're solving problems with recursion, it becomes kind of important that the compiler sort of internally optimizes a function call to the same function, like a recursive function call, that it optimizes that into an equivalent of a goto, because you don't want to sort of blow the stack when it's running a long function like that. Now, Clojure doesn't actually have tail call optimization that will do that, because the JVM doesn't. Like the Java virtual machine doesn't do tail call optimization. But there is a construct in Clojure that allows you to work around it, which is that if I define a function, I'm going to have to sort of do like a fib function, aren't I, on the fly here. So if I do a function, and anyone know how to do this? What is it? Is it like plus n? It's previous plus n, is it? Yeah. Okay, so let's make that our definition. So what you can do is this. This won't actually work.
Previous two, sum of the previous two.
Oh, so this won't work, won't it? Because the thing is, like, what you can do is you can do a call called recur. And recur will call the function with a new argument. So you could do like recur plus 1, right? But the limitation is that, so this will actually be equivalent to you having calling this function like this. Let's name it something else because it's not actually fib, like arg. So this is equivalent to this. But the lowercase will be a goto when it's compiled. Now, the limitation here is that you can't actually use the result of the recur in the expression, because then it's not a tail call. It's only a tail call if it's the last thing that happens. No.
So you can't do Fibonacci.
Yeah, no, I can't do Fibonacci like this. I can do it another way, which is a bit more clever, but I can't do it like this. Because this will actually give a compile error, because recur can only recur from tail position. I can't do anything that uses the value of the recur. There's ways to do this, but they're kind of a bit technical, so I'm not really going to go into it. I mean, if I were to do this, if I wanted to do that, I would probably just do like an infinite sequence of numbers and just grab them pairwise and sum them and reduce them, rather than writing a recursive function, because it's like equivalent. You can have infinite sequences in Clojure and just grab like the top 3 elements from it and do something with it. So it's you tend to think a lot more in terms of sequences when you're using it for real. All right. Oh, yeah. Thank you very much.